Hi everyone. Today let me explain about some basic equations related to design the belt drives. So in this basic equations, so we won't use any data book formulas and datas. Okay. In belt drives, we know that there are two types of belt drives are there. So one flat belt, another one is V belt, right? So in the V belt and the flat belt, in both cases, according to the physical design aspects. So we are dividing into first case open belt, second case cross belt. Okay. So in open belt, where we need the transmission in the same direction, right? So if we assume that this is a drive and this one is driven. So these two medium is connected with help of the belt. So here the power or the torque is transmitted from the drive to driven, right? Where the drive which rotates the driven, this side we used to say that tight side. Let me take it as a T1. And then this side loosen side we always say that slack side. Okay. So I think hope you understand which one is tight side and slack side. This type of belt where the both drive and driven rotates in the same direction, we call it as a open belt. Okay. So then when we require the rotation, the opposite side, the transmission of the rotation we required in the opposite side, we used to say the cross belt. This one is open and this belt is cross belt. Okay. So in the design aspect, we need some of the data to design the belt drive. So starting from that velocity and the selection of belt and power, considering the power and the center distance, length, and after that we will require to find the dimensions of the grooves. Okay, so so for these purposes we need design data book. Now let me explain how to calculate the belt power and tensions without using the design data book. So let me explain from the B belt. So we know that tight side and slack side. By using this tight side and slack side, we can form an equation T1 divided by T2. Right? So then this is equal to E power nu, which it denotes the frictional coefficient. Then it is multiplied with alpha. So which is alpha? What is alpha? Sorry, what is alpha? So alpha is the ramp angle. Okay. So alpha it is multiplied with cosecant beta. Okay. So beta. This beta is taken from the V belt groove angle. So this angle we say that beta. Right. So this is the equation 1. Then equation 2. By using this we can form an equation uh, according to that T1 and T2. Then to find power, the same tight and slack side, T1 minus T2 which is multiplied with velocity. Okay. So what is the formula to find the velocity? So V is equal to pi dn by 60. Okay. So then we can substitute this velocity in this formula and find out the power. So after that, to find the maximum tension, there is a maximum tension, the T max. It can be found with the help of the T1 plus Tc. So we know that T1 that is tight side tension. Then what is Tc? This is centrifugal tension. So this centrifugal tension is found with help of that mass which is multiplied with help of V square. okay, mv square. Then how do you find the mass? That is, mass is equal to, when we multiply with the density, okay, and area and the length. By using this, we can find the mass. Okay, so now we can substitute mass, and already we know that velocity by using this formula pi d n by 60. So we can find the centrifugal tension. Okay, so after that, when we substitute this centrifugal tension, adding with the tight side tension, we can find the T max. Right. So then finally, so these three equations is used to find the tensions in the tight side and slack side, and maximum tension and power. If in some cases we don't have the data for density, okay, so and also we don't know that length, another formula is there, okay, right? So that formula is to finding the maximum tension T max. So that is equal to maximum stress, which is multiple with AD, sigma into A. Okay, so when we are having the data for the stress and with multiple with A, we can get the T max. So this could be used when this case we don't have the data for the rho into A into L. That thing we can find, we can apply this formula. Right. So these are applicable for the wheel belt. Now let me explain for flat belt. In the flat belt, the same T1 T2 ratio, so tight side and slack side ratio we are using here, and E power mu, we know that it is frictional coefficient multiple with alpha. So alpha we know that is wrap angle. Okay, alpha is wrap angle, mu is coefficient of friction. This is the ratio for the flat belt. Then to find out the power, that is P is equal to T1 minus T2, which is multiple with velocity. So same thing, the same formula is used here. Velocity is equal to pi d n divided by 60. We know that d is diameter of the pulley and n denotes RPM, revolution per minute, which in the drive. Okay. Then T maximum is equal to T1 plus Tc. The same thing we followed here. Find out the centrifugal tension, that is Tc is equal to m into A into L. So m into V square. M into V square for n, which we are finding with the help of the density area into L. Okay. So same formula is carried out in the flat belt also. Okay. Right. So the area, in this case, area here in the flat belt, we are using, if this m value and density without this mass and without this equation, so when the stress value is given, the T maximum is found with help of sigma into A. Okay. So I think now you have understood to solve without the design data book. These cases we can expect in the competitive exams like GATE exam and JEE exams without using the data book. Thank you.